Okay, so let's continue with question 3. I think question 3 is less involving, and it requires more of the understanding than the mastering, okay, as opposed to question 2. So let's start. So the first question there, they're saying define what a function is, and then define the inverse of the function. So these very, very simple definitions. So this is question 3. Then I have A there. So the first one, okay, on A, they're saying define a function, okay. So a function is simply, okay, or you can say a relation. What kind of spelling for a relation is this? Okay, so we can say a relation, okay, F that maps X to Y is said to be a function, okay, is called a function, or is said to be a function, is called a function if for all values of X, okay, so for all values of X in the set X, there exists a unique, okay, very important to state that it's a unique, there exists, or there is a unique, okay, a unique Y in Y such that X comma Y, okay, is a member of that relation F. Okay, so we can see that a function is just a one-to-one relation. Okay, it's the same definition. It's same definition. Okay, so a function is just a one-to-one relation. So meaning that it's just a special relation in which each X input value has exactly one unique Y output value. Okay, so each X is mapped to only one Y. Okay, immediately you have one X being mapped to 2, then that is not a function. Okay, so this is the definition. And then let's define the inverse. Okay, so 2, so A2, what is the inverse? Okay, so the inverse, we can actually just use the same concept there. We can say a relation. Okay, we can say a relation. A relation F inverse like that, okay, which maps Y to AX, okay, is called an inverse of a function. Is called an inverse of the function, an inverse of the function, okay, an inverse of the function if for every Y in Y, okay, we have an X, okay, such that Y comma this X is actually a member of this inverse function like that. Okay, so this is the definition. So a relation, this guy here, where you have Y being mapped to X, is called an inverse of the function if for every Y in Y there exists an X in X such that the coordinate X comma Y is actually a member of the inverse function. Okay, or in other words, you can define it on here. Okay, you can say a function denoted by this, okay, an inverse function denoted by that, okay, is an inverse function if, okay, and only if F of, okay, F of F inverse is actually the identity on Y, and F inverse of F is actually the identity on X. Okay, so if these two properties are made, then this F inverse here is said to be an inverse function. So you can use this definition or you can use this definition here. Okay, they are both correct. Okay, and then let's go to B, where we are proving now. Okay, so since we know the definition of a function and an inverse, we can use those definitions to prove this and also to prove that. Okay, so this is B. Okay, so this is B. And then the first one, we want to prove that F, okay, of X1 union X2 is just equals to the F of X1 and then union the f of x2. Okay, so how do we prove that? So for us to prove that two sets, two relations, two functions are equal, we just have to show that this guy here is a subset of this, and then this guy here is also a subset of this. Okay, so for me to have f of x, then it means there's a set x where I'm getting these my x's, right? Okay, then it means there's a set x where I'm getting my x's. Okay, and then also we have to understand that when we say f of x, okay, so it means that I have an x. I have this set x where I'm getting these my x1, x2s. And it's also important to note that if I write my y, this y will actually be the same as f of x. Okay, so that our proof by letting. Okay, so we can say let y be a member of this set here, because we know that this set here represents y. So y is in that set. So let y be a member of x1 union x2. Okay, then what does that mean? Okay, it means that there's an x in the set x, okay, such that y is actually equals to f of x. Okay, such that y is equals to f of x. You can put a full stop there. Okay, so this x1 union x2, what does it mean? It means I have an x which is a member of x1 union x2. Okay, so from this one here, we can now simply use the set operation, right? We can say that from this, we know that x will be a member of x1, or, okay, x will be a member of x2. That's what we get from this, right? X will be a member of x1, or the x will be a member of x2. Okay, and then from here, we can actually see that we can actually find the f of x of this x here, even the f of x of that x here. Okay, so you can say from this, you can say therefore, okay, so therefore, okay, therefore, I will have by y being a member of f of x1, and you say, or my y being a member of f of x2. Okay, so what does it mean? If y is a member of this, and this y is also a member of this, then it means y is actually a member of what? x1, then this all tends to union x2. Okay, so you can see that I started with what we had on the left, I've ended up with what we had on the right. Okay, so here, where was that? Okay, we said let y be a member of this, right? And then we have shown that y is also a member of this. So this actually proves that the f y union x2 is actually a member, okay, of this. So we have f x1 union f x2. So we've done the proof halfway. So we can say that this is our equation 1. And then now we have to, what did I say? Here should be a subset. So now here we have to show that this is actually a subset of this, right? Okay. Okay, so we can actually do the same thing there. So you can say conversely. Okay, conversely, I don't know if the spelling is okay. So conversely, let y be a member of what we have on the right, which is this. Okay, union fx2. So this is what we have, right? Okay, so y is a member of this. Then we know that by definition, this means that y is actually a member of f of x1, or y is actually a member of f of what? X2. So this is what we get from there. Okay, so now we can say now let, okay, let an x be a member of the set x. Okay, where these x1s and x2 are coming from. That's why we are including this point here. Okay, so let x be a member of this x1 such that, okay, such that my y is equals to f of x. Okay, then from there it follows that what? It follows that my f of x, okay, which is this one here, okay, my f of x will actually be a member of f of x1, or my f of x will actually be a member of what? My f of x2. Okay, and then from there, what can we see? Okay, from there, what can we see? We can simply see that since f of x is in this guy, and f of x is also in that guy, right? So it means that my y is actually a member of F, and then in the brackets I put those two. So my y is actually a member of F, and then I put my x1 union x2. Okay, and we have shown that actually the right is the left hand side. Okay, so we've shown that x1 union x2 is a subset of f1 of f of x1 union x2. Okay, so we've shown this, and we can take this as our equation 2. Okay, and then from there we can just say combining 1 and 2. Okay, combining 1 and 2. Okay, we get that the two are equal, right? So just get f of x1 union x2 will actually be equals to f of x1, then I have union f of x2. Okay, so I get this, and then I can say hence proved like that. Okay, so we are done with the first proof. Then let's prove the one for the inverse. So what do we have here? We have this guy here. Okay, so we have this guy here, and we want to prove it. Okay, we want to prove it. Okay, so these F inverses, they are just they can be associated with the X value, right? Okay. So we are proving what? So this is 2. And we are proving that the inverse of F1, Y1 intersection Y2 is actually equals to the inverse of Y1 there. Why am I writing X? Okay. So the inverse of Y1 intersection the inverse of Y2. Okay, so these proofs are actually very similar. Okay, these proofs are actually very similar. Okay, so let's start. So since here we're dealing with the inverse, okay, so it means that the x will be the one that will be a member of this. So there we are dealing with just the function. So we are saying f of x is equals to y, right? But here f inverse of y will actually be equals to x. Okay, so take note of that simple difference. And then these y's, okay, these y's will actually what? Will actually come from the same y's. Okay, will actually come from the same y. So we can say let x be a member of this set here. So let x be a member of this intersection 2, okay? And then from here, okay, since x is a member of this, okay, since x is a member of this inverse of function, it means the y is a member of this, right? It means the y is a member of this. And we said the y is the same as f of x. Okay, so f of x is the same as the y, but f inverse of y is the same as x, okay? So if x is a member of f inverse of y1 intersection y2, then it means that the y or the f of x is actually a member of y1 intersection y2, okay? Which means that what? Okay, which means that what? So it means that actually we can find an x which is a member, okay, of the inverse of y1, and we can also find an x which is a member of the inverse of y2. Okay, so we can say this means that, okay, so this means that x is a member of y inverse of y1, okay, and x is a member of the y inverse of y2. So this is what we have there. And then from there, we can actually turn this into a one thing. So it will just be f is equals to f inverse of y1 intersection f inverse of y2. Okay, so you can see we started with where is it? Started with this, we ended up with that. Okay, so we have shown actually that the f inverse of y1 intersection y2 is actually a subset of this. So f inverse of y1 intersection f inverse of y2. Okay, so this is what we have, and you can see this is our equation 1. And then we also have to show that this is the subset of that, right? Okay. Whew. I hope my PC doesn't call. Yeah, I could lose this recording. Anyway, okay. Okay, so let's show that this is the inverse of this. Okay, so we'll say conversely, okay, if my x is a member of intersection of y2, okay, then what does it mean? Okay, then it means that the x is a member of this and it's also a member of that, right? Okay. Okay, so I can say x is a member of, and then the and there becomes the intersection, I mean, becomes the and x is a member of y2 like that. Okay, and then from here, I know that x is the inverse of this. Okay, so if x is a member of the inverse of this, it means that y is a member of whatever we have in the brackets there, right? Okay, so this means that f of x, or we can say y, is actually a member of xy, and okay, and f of this of f of x or y is also a member of what? Y2. Okay, so I have f of x being a member of y1 and f of x being a member of y2. So what does that mean? Okay, what does that mean? It means we have f of x, which is just a member of y1 intersection y2. Okay, so let's continue. So I was saying f of x is actually a member of y1 intersection y2. Okay, so if I have f of x or y being a member of this, okay, then what does that mean? It means that the x is actually a member of the inverse. So it means that x will be a member of the inverse of f of x y1 intersection y2. Okay, so we started from what we had on the right, and then we are ending with what we have on the left. Okay, so this actually means that f inverse of y1 okay, intersection f inverse of y2 is actually a subset of what we have on top here. It's actually a subset of this y1 intersection y2. Okay, and then we can say this is our equation 2. So from there, we can now say combining. Okay, so combining 1 and 2, what do we get? We get the proof. Okay, combining 1 and 2, we get that this guy here, y1 intersection y2, is actually equals to the inverse of y1 intersection the inverse of y2 there. Okay, hence proved. So we've proved, guys, we proved. Okay, so that's that. And then we can actually go to the last question, which is C. They're saying consider this function, we sketch it, we find f of a, where we have the closing interval -2 to 3. And then we find f inverse of b, where we have b in this interval. Okay, so how do you sketch modulus functions? Okay, so there are many ways. We can use transformations, or we can use redefining, or we can use substitution. So it depends on which one is simple for you. But I find substitution to be very much simple. So let's use substitution. Okay, so this is C1, where we want to state that function f of x is equals to, we had 1 minus x. Okay, so this is what we have here. So I'm going to use the method of substitution. So the method of substitution requires that we find the starting point. What requires the starting point? Okay, so how do you find this starting point here? You equate whatever you have in the modulus to 0, and then you solve for x. And then that value of x that you find, you substitute into this same function to find the value of y. So it will be that value of x, comma, the value of y that you're going to find. So we're going to get whatever we have inside there. Okay, whatever we have inside there. Okay, whatever we have inside there, and then we are going to equate it to 0. So 1 x is equals to 0 simply means that x is equals to 1, right? Okay, so this value of x that we find, then we substitute it into this function. So we're going to say f of 1 is actually equals to 1 minus 1 minus 1. Okay, so this will give you what? 1 minus 0. So it will be 1. So our starting point will just be 1, 1. And then after finding the starting point, you find the y-intercept. Okay, so y-intercept here. So y-intercept. Okay, we'll find the y-intercept. So the y-intercept, how do you find? We just let x be 0, and then we solve that equation. So we are finding f of 0, not f of 0, we're finding f of x. Oh, yeah, that's what we are doing. Eh? Okay, yeah, I wanted to get confused. So f of 0 in that function that we had, so we had 1 minus 0. Okay, so it means our y-intercept will just be 1 minus 1, which will be equals to 0. Okay, so our y-intercept will be 0, 0. Okay, so that will be our y-intercept. And then now we can find the x-intercept. Okay, so x-intercept. Okay, so how do you find the x-intercept? You let the f of x be 0. Okay, so in that function where there's the f of x, I'm going to put 0. Okay, my pages are done here. Let me bring another one here. Okay. Okay, so we had let me write. Okay, so we are finding the y-intercept, right? Okay, so we said we let our f of x be equals to 0. So it will be 0 is equals to 1. And then I have 1 minus x. Okay, so let's bring the modulus to the left. So we have the positive modulus now is equals to 1. And we know how to solve modulus equations, right? So this actually means that 1 minus x is actually equals to 1. And 1 minus x is actually equals to minus 1, right? Okay, so from here, we can see that the x value will just be 1 minus 1, which will be 0. Okay, then from here, we can see that the x value will just be 1 plus 1, which will be what? 2. So it means we have 2x intercepts. The first one will be 0, 0. Then the other one will be what? And the other one will be 2, 0. Okay, so we have everything that we need for us to sketch. So let's sketch. So I have the starting point there, which we said it was what? It was 1, 1, 1. And then I have y-intercept, which we said it was 0, 0. Okay, and then I have x-intercept, because there are 2 there. So the x-intercept, we have 1, which is 0, 0. Then the other one to be 2, 0. So we just draw the xy plane and plot those points there. Yeah, so that's simple. So if this is my y, and then this is my x, like that. Okay, so I can put 0 there. You can put 1, 2, 3, the x direction, and then that will be the y. Here I can put -1, -2, just like that. Even on the y, I do the same. Okay, so let's plot these points. So we have 1, so we are going to shade 1, there. Okay, so 1, 1 is actually somewhere there. So 1, 1 is there. Where is 0, 0? 0, 0 is there. Where is 2, 0? 2, 0 is there. Okay, and this is a modulus function, which means it just makes a v at 1, so it means I have a line that will pass through here like that, touch this point, then it will come here and it will go like that. Okay, so this is the graph of 1 minus x. Okay, so this is the graph here. So we've sketched. Okay, and then now we are supposed to where's the question? We're supposed to find this question and that question here. Okay, but my battery is almost dying, so I think I'll continue there. Let me just wait for power, then I'll continue. Okay. Okay, so let us continue. We have graphed this graph. Okay, we've graphed this graph, and then now we want to find the images of an interval A and the inverse image of this interval B. Okay, so we have that one, and then we have this. Okay, so the fastest way is just to substitute the boundary numbers of this interval into this function. Okay, but it's very much important to actually confirm your answers with the graph. Okay, so make sure that if you do direct substitution into this formula, okay, the value that you get when you have -2 and the value that you get when you have 3 should also correspond to the graph. Okay, so this is what I mean. So we have this interval -2 to 3. Okay, so the function that we have is actually this. So f of x is equals to 1 minus, and then here we have 1 minus x, right? Okay, And then the interval that we have there is from -2 all the way to 3, and -2 and 3 they are included, right? Okay, so let's try to find f of -2. Okay, so f of -2 is equals to, so we just substitute where there's x, we put -2. So this will be 1 minus, and then there I have 1 minus, I put my -2 here. Okay, the modulus. So it means this will give me what? 1 minus, in the modulus I have 1, and then this negative will multiply this negative, or it will just be 2. So 1 plus 2, it will be 3. Okay, so whatever comes out of the modulus is positive. So this will be 1 minus 3, and this will just give us what? Just give us a -2, right? So meaning that when I have a -2 as my x, I also get my y as a -2. And then let's find f of 3. Okay, so we do the similar thing, 1 minus 1, and then -3. Okay, so what do we have here? We have 1 minus, inside there we're going to have a -2, and whatever comes out of a modulus is actually a positive, so 1 minus 2, and then this will just be what? 1 minus 2, it will be -1. Okay, so meaning that the 3 there is mapped to -1, right? Okay, so f of a, meaning the interval, the image of that interval, okay, so we can say that f of a will actually be equals to, okay, starting from -2 all the way to 1, okay? But now, let's confirm this answer on the graph, okay? So if I go back to this graph here, let me change the color, maybe to red, okay? If I go back on this graph and I go where I have my 2 here, okay? So if I start here and then I start dropping down to where I'm touching this scale, you can see that it's just that this graph is not up to scale. So the -2 should be somewhere here, right? Okay, so the -2 will be mapped to -2 there. And then if I go on this 3 here, you can see that it will be mapped on what? On 1 like that. Okay, so this actually confirms our answer that the image of the interval -2 to 3 is actually these values here, starting from -1 all the way to -2. Okay, so this here will be our, oh, no, not -1. Okay, so you get the lowest value here. So within this interval from -2, from this value to this value, okay, within this interval, you get the highest value of x, the highest value of y, which we can see that the highest value of y is at 1, right? And then the what? Okay, so the lowest value there will be at -2. Okay, no wonder it's important to have a graph there. I almost got it wrong. Okay, so the highest value according to the graph in this region, okay, we can see that the lowest one is -2 and the highest one is 1. But this answer here, it gave us the lowest as -2 and the highest as -1. So this one here, when you show it on the graph, it's not actually the highest value. Okay, so here it's supposed to be 1 here. Yeah, I wrote 1. Okay, it's like I knew the answer. Anyway, yeah, so the image of this interval from -2 to 3 is actually from 1 all the way to -2. So the highest value, okay, is 1, and then the lowest value is -3 within that interval. Okay, so that's the image of that interval. Okay, and then now let's find the inverse image of this b. Okay, so even it will confirm it from the graph. Okay, so we have the inverse image of b on the interval -5 and then to 8. So this is what we have, right? Okay, so you can use the graph or you can use the formula. So you have to know the definition of this guy here. Okay, so this guy, okay, the inverse of b, inverse function of b, okay, is defined as I have an x, which is a member of the real number, such that the function f of x is a member of b. Okay, so this is the definition that you have, meaning that we can actually put in the values here. Okay, so what was the function that we had? What was our f of x? Okay, our f of x was this function here. This is our f of x, right? So we can actually substitute them into that formula. So meaning our what? Okay, you can even substitute the interval b there. So it means that I have this. So x is a member of the real numbers, such that then where there's f of x, I put my function. So I will say 1 minus the modulus of 1 minus x. Okay, and then we are saying this should be a member of the interval which is from minus 5 all the way to 8 that is included. Okay, so what does that mean? Okay, what does that mean? It means this function of f of x here should be between minus 5 all the way up to 8. Okay, so remember that this guy here represents the f of x or represents the y, right? It's not the x. Okay, because this is the inverse here. So what you have from there now is that I have an x which is a member of these real numbers. Okay, and then this guy here will be between this. So here we have a curved bracket, which means we're going to say minus 5. Okay, it should just be greater than this. So 1 minus 1 minus x. Okay, and then I'm going to say less than or equal to, because here I have a curved bracket, I'm going to put 8. Okay, so I'm going to have that. And then from there, we can actually separate these equations into two. Okay, so the first one will be the one on the left. Okay, so the first equation will be this. This will be our first equation. And then the second one will be this one on the other part. So the other one will be this one in blue now. So this will be the second equation. Okay, so let's write the second equation. We have 1 minus the modulus of 1 minus x. Okay, modulus. And then we are going to say we are going to say it's equals here. We're not going to use this in inequality. We're just going to say it's equals to 8. And then the other one, which was in yellow, we are going to say it's a minus 5 and minus, is equals to 1 minus x. Okay, and then from here, we know how to solve modulus functions, right? Okay, so I can bring this modulus with this negative the other side, and then I take this minus 5 to the other side. So our modulus of 1 minus x is actually equals to 1 plus 5. And we know that from here, we obtain two equations. The other one will be 1 minus x, the way it is actually equals to 6. And then the other one will be 1 minus x will be actually equals to minus 6. Okay, I hope you remember how to solve modulus functions. And then from here, we can find our x. So x, take it there, bring the 6 there. So x will actually be equals to 1 minus 6, which will just be what? Minus 5, right? Okay, so minus 5. And then here, our x will just be equals to what? It will be 1 plus 6, which will be x is equals to 7. Okay, and then if you take a look at this one here, okay, if I try to make an equation from here, I'll say this modulus has a negative. Okay, so I can take it that side and then I bring the 8 this side. So I'm going to have 1 minus x is equals to 1 minus 8. Okay, so it means we have modulus of 1 minus x, which is equal to minus 7. Okay, so but the rules of modulus, we know that this statement here will be false. Why? Because you cannot have an expression which is in modulus being equal to a negative number. So here we'll find no solution, right? So here we'll find no solution. So it means the only answers that are possible is from minus 5 to 7. Okay, so the inverse of this b would just be from minus 5, okay, all the way to 7. Okay, so the question can be, should we include 7 or we should not? Okay, so remember, we found that 7 by using this part here where we had this one, the less one, the less than sign. Okay, so here it means even the 7 are not including it. Okay, so you can actually show this on the graph. Let me just get blue and then I go back to the graph. So if I go back to the graph, what was our interval for b was minus 5 to 8, right? Okay, and remember that this minus 5 to 8, okay, that minus 5 to 8, it's the y values. Okay, it's the y value because we are talking about the inverse, they're not the x values. So meaning if I come here where my graph is, okay, this was our graph, right? Let me just zoom in a little bit. Okay, so if I have something like that, it means if I want to draw minus 5 all the way to 8, and I know that this is an interval in the y, it means down here I have to go to somewhere where I have minus 5. Okay, and then up there I have to go where there's 8 there. Okay, so where there's minus 5 here, I'll go this direction until I meet this curve here that is coming like that. That line. Okay, so you find that where it's meeting here, it will be on minus 5. Okay, and then even this side, I'll go that direction until I meet this guy here. So it's just that I've not drawn it to as accurate as I can. So where it's meeting here, if you draw it accurately, you will find that this will be 7, right? Okay, so within this interval in the y from 8 all the way to minus 5 here, okay, the lowest x value that we can find will just be minus 5, and the highest will be 7 there. Okay, will just be 7 within this negative 5 to 8. Okay, so that's how we get our answer there. Okay, so this is actually our answer there. Okay, so we are done with the test 1. I'll upload the video, then I'll share in the group. Okay. Have a blessed day.